grab my kids too then.
Yeah, that's fine. Levi and I'll go over Ryan's submission, and I'm going to do it in 15 minutes because I got to
You guys will still be here saying
take a
this.
phone call. Yeah, yeah.
That makes it a lot faster.
Okay, thank you. Okay, so Ryan, I'll respond here on the to-do. Thanks for the response. Checking now. Okay, so solar car 2015 camp. Here we go. All right, so Ryan, your remarks are in black, mine are in red. Lighten up the wheel assembly. Yes, that is always true. I think we can do so with bike parts. That's probably also true. What's the current mass of the wheel assembly? What's the proposed mass? He cannot see the spreadsheet. I think it's there though, right? Isn't it? Isn't there a mass budget?
Yeah, I think there is somewhere.
Okay, here's the mass budget right here in the shell. There we go. Okay, so it looks like, unfortunately, this is in a PDF format. So what I'm going to ask you to do, Ryan, and this should only take, gosh, 10 minutes, but just take this, please, Ryan, and turn this into a Microsoft Excel editable document. The mass budget is right there, and then you can put in the wheel assembly that you're proposing, and then we can, see how it compares to the previous one. So that'll be a good task for you. Okay, see lecture. We found it. Kindly update in MS Excel. Okay, so that's for next week, Ryan. Having difficulty locating a tire at 16 inches. Yeah, I'm just thinking we're going to have a hard time finding an 80 millimeter tire on a 16-inch wheel.
I found one that fits 20-inch wheels.
Okay. This says wheel size has to be 15 to 17 inches.
Well,
is 20 inch too big?
They're 20-inch bike wheels, which, like, the actual rim size is 16 inches.
Okay, right,
But
okay.
I think bike wheels are sized like with the tire.
That's right.
Yeah.
Mm-hmm.
So I mean, it fits a 20-inch wheel, which is 16 and a half, and then it's
Okay.
a 80 or 90 something wood
Okay.
tire.
Okay. Okay, so I'll say Levi found. Let's purchase. If it looks ready to roll, I'm fine going ahead and buying it. Okay, let me tell everybody right now what the coefficient of rolling resistance is. It's very simple. And you don't have to wait for your physics class to do it either. So I'm sure in your physics class you've seen the coefficient of friction. And the coefficient of friction is just a number between 0 and 1. And it's telling you, so if I'm pushing down, so the number n is how hard I'm pushing down in force, F sub f is how much I'm pushing horizontally. And mu is just telling you the ratio between those two numbers. It's that simple. So so if the car weighs has a weight of 400 pounds and the rolling resistance is 0.1, then the car is going to be resisting 40 pounds of force. It's that simple. Now the rolling resistance numbers are typically much smaller, and I think there's going to be a table down here somewhere. They're tiny. There it is. Obviously smaller with a rail car. So here's, and they even have right here on Wikipedia, Michelin Solar Car tires, 0.0025. So with that, Ryan, you should be able to put together just a little model, and the equation that you want to start with is, well, when you've got F equals CRRN. So again, N is the normal force, and I actually covered this in a previous lecture. I'll do it again right now. So if N equals, and let's just say N's going to equal 1 kilogram is 10 newtons. If the car weighs 200 kilograms, if it has a mass of 200 kilograms, it's got a weight of 2,000 newtons. 2,000 newtons. And CRR equals, well, Michelle, let's just say it equals 0.003, 0.003, then F equals, so what are we looking at, 2,000 times 0.003 equals 6 newtons. And now we know that, and let's go back to the equation. Physical formulas. What I need to find here is what I just want to find the equation. Rolling resistance as a function of velocity. Because what we're going to find is, since power is force times velocity, velocity increase. So this guy, so we can see the rolling resistance is not a function of velocity. The normal force is not, but what ends up happening though is the rolling, the faster you go though, the more it's linear. That's what I guess what I'm trying to say here.
Got one website in that search.
What's that?
Oh, I don't know if I saw it in that search.
Yeah, this is the deal. It's not directly proportional to physical force. This is a calculation for it, but we can more or less we can measure it Sorry, I don't have that, the full formula in front of me at the time being. But let's just go back into this guy. The force equals 6 newtons. And so that means that the power from rolling resistance is going to equal the force times the velocity. So this is going to equal CRRNV. Okay, that's what I was looking for. So if we know the coefficient of rolling resistance, we know the weight of the car, we know how fast it's going, that's telling us how much power is going into the rolling resistance. So that's more or less what we're looking for. Now, less data than I need. The thing to do here, Ryan, is just build a model. So use your physics, build a model, and from this, you can tell us at 15 miles per hour how much power is going into the rolling resistance. So hopefully that's pretty clear. I mean, it's just a little bit of algebra. If you need help with it, though, let me know. Okay, 80 millimeters, I think we've got that dialed in. So let me, I'll shoot an email out to Samantha Hines. Bicycling Science. Sam, could you please order a copy of Dave Wilson's Bicycling Science? Thanks, Brad. Okay, so Sam, one is on the way. All right, so I agree. Maybe we will end up doing a little change with the motors, multiple motors. In fact, Lee and Levi are going to work on that here in a second. I like the idea. Nothing wrong there. We might end up with the 400-watt motors, molded plexiglass for the seat. That's fine. I don't think. Yes, we do have a bench seat. Super. Okay. Well, thanks for looking at that. Okay, so I'll say, yeah, let's keep your statements in black, Ryan. Mine can be in red. Please continue to research propulsion. Okay, well, I gotta go, got a quick little meeting here, but I will save that, take a break, and I will be back, and we're gonna do a little motor testing, and I'll have Levi kind of take the helm, do some updates, and then Lee as well. So I just gotta duck out here for a second.